Okay, this lesson's on using coterminal and reference angles to find sine, cosine, and tangent. We've already talked about coterminal angles. Those are angles with different measurements that put you at the exact same spot on the unit circle and have the same sine, cosine, and tangent. Reference angles are related. So the definition of a reference angle is the acute angle formed by the terminal side of an angle in the unit circle and the x-axis. And that's a bit of a mouthful. That's kind of confusing. But here's what it looks like. So I'm going to draw an angle here. This is going to be a 210 degree angle on our unit circle. So 210 degrees. To find the reference angle, we're going to take the terminal side. So that's the side on the left here, and make an angle with the x-axis. So the x-axis comes out right here. And if you make an angle there, this angle would be 30 degrees. And we can tell it's 30 degrees because we know the x-axis is at 180. Our angle is at 210, so that's a difference of 30. So what we'd say is for a 210 degree angle, the reference angle, and we denote that with a theta. Theta is our variable for angles. We put a little line over it, a little bar over it. And that tells us it's the reference angle. So the reference angle is 30 degrees. Let's do one more here. Let's do a negative one. Let's do negative 120. And let me get a different color so this doesn't get too messy. So negative 120. So again, we're going to start in our usual spot. We're going to go clockwise this time, 120 degrees. That's going to put us right here. So that's where our angle puts us. It puts us at 240. It's negative 120. But to find the reference angle, what we need to do is find an acute angle formed by this side that I just drew and the x-axis. Well, to do that, I'm going to use the left side of the x-axis again. I'm going to make an acute angle right here and figure out how many degrees it is. Well, if I'm at 240, the x-axis is 180. That's going to be a 60-degree angle. So my reference angle for negative 120 degrees will be 60. And we'll look at that some more as we go along. So if you're not quite clear on that yet, don't worry. Here's what I want to point out about reference angles, and here's really why we use them at all. If you look at a 210 degree angle, the first angle we drew in yellow, you can see its sine and cosine right here. The sine is negative 1/2 and the cosine is negative square root of 3 over 2. If you look at its reference angle at 30, the sine is positive 1/2 and the cosine is positive square root of 3 over 2. So the same thing's going to happen with the negative 120 degree angle and its reference angle at 60. You're going to get the exact same absolute values for sine and cosine and tangent. The only thing that would change is the signs. So the reference angles are kind of what's determining all these other angles on the unit circle. And one thing you'll notice, because the reference angles are acute, they always end up being in the first quadrant here. So when we're working with our major angles, you're going to get 30, 45, or 60 as your reference angle. And that is a quick way, if you can memorize those three, to then be able to find the sine, the cosine, and the tangent of any angle that you're looking at. So here we go. We're going to just do some examples of what I'm talking about here. It says, find a coterminal angle with a measure between 0 and 360. That's our first task. Use the unit circle to find the sine, cosine, and tangent of that angle. So that's our second thing we got to do. And then we got to find the reference angle. So 480 degrees is our first one. So the first thing we want to do is find a coterminal angle with a measure between 0 and 360. This is how you do it. You start with your angle. And to find coterminal angles, remember, we add or subtract 360 degrees. Well, if I want an angle between 0 and 360, I'm going to need to subtract to get there. I need to get smaller. So I'll subtract 360. I get 120 degrees. So that's what I'm looking for. It's a coterminal angle. It's between 0 and 360. So I go ahead and make that on the unit circle here, 120 degrees. I can see at 120 degrees, my sine My sine is square root of 3 over 2. Sine is our y value. My cosine is negative 1/2. That's the x value. And I wrote sine again. I don't know why I did that. Let me fix that. And to do my tangent is sine over cosine. So I'm going to work that out over here on the side. My sine is square root of 3 over 2. My cosine is negative 1/2. Sine over cosine, the 2's cancel out, and I get negative square root of 3 over 1, or just negative square root of 3. So it may be a little confusing what I'm doing here because I'm writing sine of 480, cosine of 480, tangent of 480. But on the unit circle, it's clearly at 120. And so that goes back to what we talked about right before the break about coterminal angles. Coterminal angles put you in the exact same spot of the unit circle, and they have the exact same sine, cosine, and tangent. So if 480 and 120 are coterminal, if you find the sine, cosine, and tangent for one of them, you find the sine, cosine, and tangent for the other one. Now our last task here is to find the reference angle. So to do that, I'm just going to switch colors, and we're going to use our x-axis and make an acute angle. So you use whichever side of the x-axis will make that acute angle. And here, since we're on the left side of the graph, it's going to be the negative side of the x-axis. And we look right here. This is our acute angle. And we just figure out how many degrees that is. So we're going from 120 to 80, or 180. 120 to 180 is 60 degrees. So our reference angle is 60 degrees. So I think if you, and on the assignment, you have a picture of the unit circle to work off of, and I think that's going to make this a lot easier than if you were trying to do it without. Second example with degrees, and then we'll do a couple with radians. We have negative 120. This is actually what I did on my example earlier. Negative 120 puts you right here. But let's go ahead and do this the same way. To find a coterminal angle, we add or subtract 360. Since we're negative, we need to add 360. So 360 plus negative 120, which ends up being 360 minus 120. And you get 240 degrees. That's your coterminal angle. And that's what we see here on the graph too. That's where we end up at 240 degrees. So now we can look at that 240 and find the sine, cosine, and tangent. And I can actually write negative 120. So I don't know why I wrote theta. So sine of negative 120 degrees, that's our y value, is negative square root of 3 over 2. The cosine of negative 120 degrees is negative 1/2. We've already worked with these two numbers to find tangent, to do sine over cosine. The only difference is the signs. Here we have two negatives. So we know our tangent of negative 120 degrees has to be positive because it's going to be negative over negative. So it's going to be positive square root of 3. So that's our sine, cosine, and tangent. The last thing we need to do is find a reference angle. So again, we're on the left side of the graph. So we're going to use the left side, the negative side of the x-axis. So this right here, and make an acute angle. And that acute angle, again, is going to be 60 degrees. So that's just coincidence that I chose two of them that had the same reference angle. But it's also a good illustration that you have two angles that are in different quadrants of the graph. One's positive, one's negative, but they end up with the same reference angle. You end up using the same numbers for their sine, cosine, and tangent. So our reference angle is 60 degrees. All right, let's do a couple with radians. We have 11 pi over 3. So now to do this, to find this angle, and for radians, it's not 0 and 360, it's 0 and 2 pi. Because remember, 2 pi in radians is 360 degrees. We need to, instead of adding and subtracting 360, we need to add and subtract 2 pi. So here I'm going to take my 11 pi over 3 and subtract 2 pi. Well, 2 pi, if I make that into a fraction with a denominator of 3, is going to be 6 pi over 3. When I subtract that, I get 5 pi over 3. So I just need to check really quick, is that between 0 and 2 pi? Well, I know 2 pi is 6 pi over 3. This right here is less than 6 pi over 3, so it hits in the right range here. So 5 pi over 3 works. So now I want to find 5 pi over 3 on my unit circle. So I start my usual spot. I go counterclockwise until I get right here. We see 5 pi over 3 right down here. So that is my coterminal angle, 5 pi over 3, and my sine, cosine, and tangent. You can see we've got the same numbers here. So my sine of 11 pi over 3 is going to be negative square root of 3 over 2. My cosine of 11 pi over 3 is going to be 1/2. My tangent is going to be sine over cosine again. And we've already worked that out. We know if we do sine over cosine, we get square root of 3. It's just a matter of the sign. Since I have one negative and one positive, negative divided by a positive gives me a negative. So my tangent is negative square root of 3. Reference angle. So this is, you'll notice, is the same reference angle as we've had for the other two. Again, even though it's in a different spot on the graph. But we are in radians here, so we need to make sure our reference angle is in radians. So here we go. We're looking for this angle right here, formed between our terminal side and our x-axis. This time we're on the right side of the graph, so we're going to use the positive side of the x-axis. We've got to figure out what this is, and there's a couple ways you can do it. You can kind of look, kind of reflect it up here and see what the same angle is up top. Or you can think, okay, this is 5 pi over 3. Right here is 2 pi, which is 6 pi over 3. So this angle here would be pi over 3. That's the difference, is pi over 3. So our reference angle here is pi over 3. It's a little trickier with radians because it's not as easy to just mentally subtract it like you can with degrees, but it's the same idea. One more, negative radians. So we have negative 23 pi over 6. So same idea. We've got to get between 0 and 2 pi. So we know where this is on the graph. Here, since we're negative, we need to add 2 pi. So I'm going to start with negative 23 pi over 6. I'm going to add 2 pi, which since we're over 6, that's going to be 12 pi over 6. And when I do that, I will get a negative 11 pi over 6. Well, I'm still not between 0 and 2 pi, so I need to do it again. I need to find another coterminal angle, and hopefully this one will be in the right spot. So now I'm going to take negative 11 pi over 6 and add 2 pi again. So I'm going to add positive 12 pi over 6 one more time. And when I do that, negative 11 and positive 12 gives me positive 1. So 1 pi, or just pi, over 6. So my coterminal angle here that puts me in the right spot between 0 and 2 pi is pi over 6. So now I'm going to graph that, or I'm going to find that on the unit circle. Start in the normal place, go counterclockwise, and right away I'm going to hit pi over 6. So pi over 6 is my coterminal angle. And I'm going to find my sine, cosine, and tangent. So my sine this time, and it's 23 pi over 6 is what I want to be writing down here, since that was my original. So let me make sure I write the correct thing here. So the sine of, and it's negative 23 pi over 6, sorry. So the sine of negative 23 pi over 6 is my y value there, which is 1/2. The cosine of negative 23 pi over 6 is the x value, and that is square root of 3 over 2. Our tangent is going to be a little different. I mean, it's the same numbers, but they're in different spots. This time, the 1/2 is the sine. Square root of 3 over 2 is the cosine. So if we work this out, I'll work it out over here on the side. So tangent of negative 23 pi over 6 is sine over cosine. So 1/2 over square root of 3 over 2. The 2's cancel out again. We get 1 over square root of 3. And we could leave it like that, but we really don't want to. We want to rationalize the denominator. So we'll multiply top and bottom by square root of 3. And our final answer here, which I'll squeeze in, is square root of 3 over 3. So tangent of negative 23 pi over 6 is square root of 3 over 3. Okay, so that's our sine, cosine, and tangent. And hopefully those are starting to become familiar, because once you get an idea of, especially the pi over 6, pi over 4, pi over 3, what the sines, cosines, and tangents are of those, then I think it just starts, all this stuff becomes a lot easier when you just have that like top of mind, and you don't really have to think about it. So that's our sine, cosine, and tangent. Let's find the reference angle. The thing you'll notice here is when you're in the first quadrant, your reference angle is just going to be the angle itself, because if we make an acute angle with the x-axis, it's just going to be the exact same angle we already have, which is 30 degrees, or in radians is pi over 6. So our reference angle for this angle here is pi over 6. It's the same as the coterminal angle we used. So hopefully that makes sense. We'll have a chance to go over this some also on Wednesday if you get stuck on it.